Right, here we are again, and let's draw some trees in BCPL using turtle graphics and recursion. So what I've done is I've actually started the project. There it is. This is just a little bit of boilerplate, little comment. Lib header is the BCPL equivalent of stdio.h. Math and VDU are a couple of things that we need. D2R, our turtle angles work in radians, but we want degrees. So there's a little function, D2RD is the hash times and that constant m deg to r. So BCPL floating point was a little bit of a late addition, so it doesn't automatically look for floating point numbers like C or other languages do. So you've got to be a lot more explicit. So anything floating point, you need the hash in front of. Otherwise, it treats it as integers with interesting but unexpected results. So you've got to be careful with that. Anyway, so let D2R, degrees to radians, and tree length. That's a bit of a mistake there. Lim be empty function and start equal val. So there's a few mistakes there. Let's just fix up my quick typos because I don't know what was going on there. And we do need brackets there. And if we really wanted to check this, we could write it out, quit BCPL compile tree to bracket missing. Yep, we'll start there. Anybody spot the mistake? Yep, there you go. Comma. Control X, Control Q. Quick compile. Yeah, I mean, it's not going to do anything. It'll do nothing. So, but at least we've got a working place to start. Right, moving on. So, our tree. Nothing special. We're going to be recursive, so we need a get out of jail free ticket. Now the limit is the number of times we're going to go down. That's the number of little branches that we're going to go to. So if limit ever becomes less than 1, caps lock, then return. That'll give us a get out of jail, as long as we remember to decrement the limit every time we call it. So what we're going to do is we are going to move. And there's our length, and it will be when I... Something wrong with the E key on this keyboard. It needs a good hard push. Move length, and then we turn to the left. Turn our angle. And then we do it again. So we go up, we go left, we go along, we go left, we go along, and so on until we've done it enough times. So at this point we go tree, and how we need to reduce the length. It's an integer, so we don't need to worry about our hash times. If we go 2/3, so 2/3 is 67 over 100. Ish. Now we need our angle, same angle, because we're going to turn the same angle every time, and limit minus 1. So we're going to call ourselves again, which goes length, turn, length, turn, length, and every time we move, we're getting shorter in the length, and we're getting 1 down on the limit. And then we do it again, but this time we turn to the right. So, oops. Turtle turn But because we've stepped to the left by angle, we need to step to the right by double the angle. And it's negative because we're going to the right. So negative, we're doing floating point because the angles here are floating point, 2.0 times angle. So we go there, and then we go doink, doink, and we go there. Okay. So, and now we do it again, basically. So I'm gonna, because I'm lazy, I'm gonna use cut and paste. And it's exactly the same thing. So we do everything to the right again. And at this point, we need to turn back to the middle again. So we're now going to turn back one. That will turn one of our angles. And that gets us back to the same place. And then we're going to move back to where we came from. Turtle move. And we're in there. And it's negative. And it's an integer, so we don't need the hash line. And that should be our little function. So let's go down to our main. We're going to start off by turtle init. That just sort of resets a few things. I'm going to pick a colour for it. Actually, leave the colour. When you do the turtle init, the colour should be white. We'll leave it at white at the moment. Now move to is an absolute move. Our screen's 320 wide, so we'll go 160 along. Make sure we are at the bottom. And then see if we can draw a tree. See if this works. So we'll start off, let's start off with a length of 80. An angle of 15. Tell it's 15.0, so it knows that it's a floating point number. We'll do it 10 times. See where that gets us. With a bit of luck, that might work. So let's write it out. Quit. Compile our program. No errors. Does that mean it's going to work? Who knows? No. Now, why could it not be working? Could be because there's no colour. Or it could be, I've just realised exactly what the problem is. The problem is we didn't put the pen down. There we go, turtle pen 1. Yeah. So turtles aren't going to work unless you actually tell them to stick their tail in a bottle of ink and then draw it. There we go. And there we go. Excellent. One tree. That's quite quick. Let's edit something else in. Give us some more. Let's go, if we go a little bit, 25, let's go deeper. 20. Should make it a little bit denser. Oops, Control X, Control Q. Compile, and taking its time. Have we gone too deep? Is it going to take too long? Should I have tested this? Yes is the answer. How long are we going to wait? So I think in these circumstances we just say, right, I'm going to give you 5, 4, 3, 2, 1, nah, and that's game over. Let's switch it off and switch it back on again because I don't yet have interrupt working. So, was that just too long? Was 20 just too long for it, too big for it? Let's take it back to 10. See what happens. Doesn't remember history between power cycles, unfortunately. Compile it. Yeah, so I think it was just taking a little bit too long to go down. Edit it. And what happens if I take it down? It could be running out of stack space, but I wouldn't have thought so. It's only going down 15 times. Of course, compiling it every time to change a value is not a good idea, so maybe I'll go and modify this. And yeah, there we go. It took its time and it drew it a little bit longer. Anyway, there you go. We can do trees and turtle graphics and using recursion. I'll go and edit the program off camera just to make it a little bit. I've got some ideas. We can make this nice and interactive, nice and fun. And I'll do a separate wee video for that. Anyway, see you next time. Bye.